I'm Anil Kumar. Welcome to my YouTube channel and the website globalmathinstitute.com. In this video, we are going to discuss about angles, parallel lines, and take up some composite figures to provide solution based on the concepts learned. This video is for our middle school students, grade 7, 8, and I hope even grade 9 students can benefit from it. We'll talk about angles and lines. We'll begin with the classification of angles, look into the properties of angles. We'll have quiz type of questions as we move along. Most of the questions can be seen in test papers on this topic. We'll talk about what are complementary angles, what are supplementary angles, what is a transverse line. Now, whenever you have two or more lines and they are cut by another line, that line is called the transverse line. Now, we could have two cases. Those two lines could be parallel or they may not be parallel. We'll consider those cases and also look into different types of angle pairs which are formed in such case, namely the alternate angle, the corresponding angle, co-interior angles. We'll also figure out the conditions for parallel lines and do some examples to understand the concept. I will leave some questions for you as exam practice. The figure here clearly shows what we are going to cover in this particular video. Let's begin with the angles themselves. Angle, which is shown here, right there, is formed when two rays begin from a point. This point is called the vertex of the angle, which normally we write as letter O, but you could use any letter here. Normally, capital letters are used for writing the vertex of the angle. 2 points on the rays and the vertex actually define the angle. So this angle, which we are showing as angle O, could be written as angle. This is the sign AOB. We could also write this as an angle AOB, where this angle on the top of O, right? So that is how we could also say. Sometimes we use Greek symbols like alpha, beta, gamma, theta. The symbol used here is theta. It is said as theta, Thita, right? So that is how you say the word theta. So that's the angle which we have shown. So from here, you got a concept about angle. Here is the summary. The angle theta with vertex O is formed by the intersection of the rays OA and OB. The two rays are called initial arm and the terminal arm. So the ray from where it starts, this ray will be called as the initial arm. Let me write here, initial arm, and the other ray is the terminal arm. The size of the angle is the amount of turning or rotation from the initial arm to the terminal arm. So this rotation is the angle which we talk about. More the rotation, greater the angle. So we'll refer to this as the measurement of the angle, or broadly speaking, size of the angle. Angle in counterclockwise direction is considered positive. So this direction, counterclockwise direction, we always consider that angle to be positive. While in higher grades, you will learn more about negative angles and also angle measurements in another unit called radians. In this particular lesson, we'll focus on degree measurements. Angle in counterclockwise direction is considered positive. Angle AOB or angle AOB as written here are common ways to write the angle. This is called three-point notation. Since we have these 3 points, it has a name which is called three-point notation. Greek symbols, numbers, and alphabets are commonly used to name angles. Common Greek symbols. It is good for you to know which are the common Greek symbols which we normally use. This is alpha. then that symbol is beta, that is gamma, and that is theta. These are very commonly used. Negative angles and the measurements in radians will not be considered in this level. Okay, we'll focus on positive angles. All angles for us will be positive. Okay, and the measurements will be in degrees. So we'll do angle measurements in degrees only. Correct. Now let's try to classify these angles. There are many ways to classify them, but this is the most popular one. Angles are classified based on the fraction of complete turn about a point. So, about a point means it is kind of a full circle, right? So, we'll always compare angle with respect to a point. So, at a particular point, we have an angle of 360 degrees. So, this circle, full circle here, actually, if you make, is called an angle of 360 degrees. So, in our discussion, when we say one revolution, so which is the first type of an angle, one revolution means one complete turn, and that turn will mean 360 degrees. Correct? So, that is what we mean when I say one revolution. Now, let's see what is straight angle. So straight angle, as the name suggests, is kind of a straight line, and if that is the vertex, then the initial arm moves and goes there so that the sides are actually right opposite one another. So that is called the straight angle. Now that is also half turn, right? Not a full turn, half of the turn. So in this case, that revolution, that angle, half turn angle, is 180 degrees, right? So straight angle is equal to 180 degrees. So half of revolution, I should say, okay? And this is quarter turn means quarter of revolution, 1/4 of revolution. Now, in this particular diagram here, the straight angle will be the line shown. So that is the straight angle, correct? Right angles. Now, right angles are the quarter turns. So we have mentioned quarter turns. It really means that if I have a straight line, then we'll do not quarter means up to this place, correct? So that is the quarter turn. So this is how we make a 90 degrees, and normally in the figures we'll show it with this 90 degrees. So that is how this angle will be always shown. Okay. So in this diagram, the angle shown 90 degrees is right there. Okay. Then we also have angles with a range of values. We call them as acute angle. The acute angle is less than a quarter turn. So that means anywhere in between these 0 degrees and 90 degrees, right? So that is your 0 degrees and this is 90 degrees. So anywhere in between, it is acute angle. Is that clear to you? So the angle measurement will be somewhere in between, kind of like this. Less than 90 degrees, greater than 0 degrees. Then we have obtuse angles. Obtuse angles really mean that the angle will be greater than 90 degree but less than 180 degrees. So this initial arm will go kind of like this. Do you see that? So it is greater than 90 degrees. However, it is less than 180 degrees. So it is in between 90 degrees and 180 degrees. And then we'll talk about reflex angles. So the reflex angles, they are greater than 180 degrees. So the angle, which could be something like this, will be a reflex angle. So where you can see that the angle formed is more than 180 degrees, correct? So these angles are between 180 degrees and 360 degrees. Right. Now, you can use a protractor to create these angles. So normally, we'll be using a protractor to create angles. Okay, let's move on and take some examples. In example 1, consider the figure to provide two examples of each type of angle, right? So we had understood the classification. Let's see. Uh, how do we identify? Straight angle. So figure out which angle could be a straight angle from the given diagram. Right angle, acute angle, obtuse angle, and reflex angle. So pause the video, take your time, answer, and then look into my suggestions. Now, straight angle means a straight line, so we can say that the angle AOD, right? So AOD is a straight angle. Another angle, the other straight line BOE, right? Because the angle BOE is another straight angle in this particular case. Now, right angles are at 90 degrees. Now, in this particular case, I forgot to write like this. This was a right angle here. So that is the right angle. We normally make this sign to show that this is a right angle. So here the right angle is EOC, right? So can I write this as angle EOC? The other angle is BOC. Acute angles, as you know, acute angles are less than 90 degrees. So the angles which are less than 90 degrees in this particular case could be AOB. You could also write angle EOD. Obtuse angle is more than 90 degrees but less than 180, right? So in that case, we could have an angle which is uh, DOB, right? So angle DOB. Sorry, that would be a reflex angle. So the obtuse angle in this particular case will be AOC. So you can see that this particular angle AOC is obtuse angle. It is greater than 90 degrees, but it is less than 180 degrees, correct? Another angle which you could see here along with it is the angle BOD. So we'll take angle BOD as an obtuse angle. Now, reflex angles are greater than 180 degrees, and so we can have the angle DOB as reflex angle. Another reflex angle could be AOE. So, so we're trying to say that this angle AOE means this angle. Is that clear to you, right? So we prefer to move counterclockwise to show that that is how the positive angles are normally taken. Okay, now here is a question for you to practice. Now with the protractor, I would like you to give a question. Draw the following angles. A 120 degrees and B 300 degrees. So let this be an exercise for you. Example 2. The question here is, draw a freehand sketch of the following angles. So one angle given to us here is straight angle. Then we have to draw a right angle, acute angle, revolution, which means 360 degrees, and a reflex angle. The measurements are not given, just a general angle, right? So you could draw a straight angle means a straight line. So in that case, we'll just draw a straight line like this. You may draw the arrows at the end. Otherwise, we'll assume that the arrows are there at the end of the line. But it's kind of important to label your angle, right? So let us say this point is A, O, and B. So that becomes, sorry, we are given straight angle PQR. So we'll write PQ and R. So PQ and R. Is that clear to you? So that becomes the straight angle. Now let me draw the right angle. So let's use a different ink to draw the right angle here. So that becomes the right angle. It is customary to show right angles with this sign, right? So that becomes a right angle. we want to label this as ABC. That means B is the vertex. That is kind of important, right? So B is the vertex, and that becomes the angle ABC. And now we'll draw an acute angle. Acute angle means less than 90 degrees, correct? So that will be an acute angle. Let's label it DEF. So that is D for us, and this is E, and that is F for us. So that becomes the acute angle. As far as the revolution is concerned, it really means a point. So what we do here is when we have a point like this, we actually draw one line, which is the initial arm, right? So we have to go one full circle like this, and that becomes the revolution angle, and we label this angle as T. Is that clear, right? So that is how we are going to draw this particular angle. Reflex angle. So for reflex angle, it is greater than 180 degrees, and therefore we'll take a point MON. So M, right, O, and N. So we prefer to move always counterclockwise to say that, well, that is how the angle is, and this is greater than 180 degrees, less than 360 degrees, right? That is how we'll draw these angles. Now, there's another very important point to note, that the angles can be greater than 360 degrees. Can you tell me why? Well, let's say you're playing on merry-go-round, right? So if you go circles after circles, right? So every rotation adds to 360 degrees, right? When you start from here, one full circle, then again you go like this. So that means you could go and you can have more angles. Do you see that? So if you go many circles around, you keep on adding 360 degrees. Do you get the idea? Correct? So basically, if I have an angle of 400 degrees, right? So 400 degrees will be what? 400 degrees angle will basically mean that I go one full circle, which is 360, and then 40 more. So that is how I'm going to sketch 400 degrees. Do you see that? So this angle here will be only 40 degrees. However, one full circle will give us 360 degrees additional, right? So that is how we may even draw an angle which is more than 360 degrees. Is that clear to you? Okay. So let's move on. Take example 3. Now, this is a very interesting question. I'd like you to pause the video, read the example, answer it, and then look into my suggestions. Question here is, identify all the acute angles formed at the vertex O. Write these angles using 3-point notation. So we'll assume these points A and B to be somewhere on the ray and O to be at the vertex, right? So let's identify these acute angles. Well, if you have the case as in A, there is only one angle here, and this angle could be written as AOB, right? So in this case, we have only one angle. Okay. Now, how many angles do you identify in the second case where we have a vertex O and three rays? In that case, how many angles are there? Well, this is one. Let me write down. Angle COB. Let me write BOC. That'd be better. Or because we want to always go from this side, right? So I'll write this as angle BOC. Okay, that's one. And then I could say angle AOB. Okay, angle AOB. Is there any other angle? Well, also angle AOC. Do you see that? So in this case, we have three angles. In the first case, we have one angle. Correct? Now, when you have four rays going on, how many angles can you form? Well, here is a hint. There are six angles which can be now made, right? So now you can make six angles. So I'd like you to write down all the six angles here. Perfect. So you know that if there are four, then we have six angles. Now here is a question for you. Let me call this as question number 2. So question number 2 for you is, How many acute angles can be formed by 10 rays? By 10 rays, how many acute angles can you get? So I'd like you to look into the pattern rule and then answer the question. Is that okay? So pattern rule here is, let me share with you the rule. Whatever we have learned. So if we have two rays, right? Two rays, in that case we have one angle, three rays. In that case we have three angles, four rays. In that case we have six angles, right? So you have to look into this pattern and then answer what happens when we have 10 rays. Write down your answer in the comments. I'll also provide you the solution later. Okay, so 10 rays, what is the number of angles? Acute angles, right? Maximum number, right? So think about it. Let's move on and take the next example, which is example 4. Find the size of following angles from the given measurements. Drawing is not to the scale. That means don't use protractor to just measure, right? So these are just the angles given to you. Now you need to find what is the angle BOD. So let's look into it. BOD, that means you want to find that angle. So it's good to visualize it. We can say that is equal to sum of these two angles, which is 40 degrees plus 36 degrees, correct? So you could do this and then we get 76 degrees as our answer. So that is how this question is to be answered, correct? So I hope the concept is clear. Now let's look into the angle AOD. So AOD means, oh my God, this angle. So that really means you have to add all three of them, correct? So let's add 36 degrees to 40 degrees to 30 degrees, correct? So you get your answer, which will be 347 and 310, 106 degrees, right? So it is an obtuse angle in this particular case, and that's what you get. So I hope you got the idea how to do it, right? That is how you have to do this question. Angle AOC. So in that case, angle AOC is this particular angle. I'd like you to add both, which is 30 degrees plus 40 degrees, and what you get here is 70 degrees. Now D is reflex angle DOA. So the reflex angle DOA really means this angle which we're talking about. So what is the measurement of that angle? Well, what do you think it is? Well, we know at a point, what is the angle? It is 360 degrees, right? So it should be 360 degrees. Take away sum of the angle AOD, which was 106 degrees, correct? So when you do the difference, you will find the reflex angle. So 10 take away 6 is 4, 5 take away 0 is 5, and 3 take away 1 is 254. So we get 254 degrees. So what I'm writing here is the unit in degrees, right? So when we write this small circle on the top, that is degrees. And you should read it as degrees. 36 degrees, 40 degrees, and 30 degrees, okay? Example 5. Are the following statements always true, sometimes true, or never true? You need to explain. These are very tricky statements. I'd like you to pause the video, understand each statement, then answer. The very first one is sum of two acute angle is an obtuse angle. Okay. Second statement is sum of two obtuse angles is a reflex angle, and C is two intersecting lines will form four angles, and D is two intersecting lines will form two straight angles, right? So these are the four options. I'd like you to go through them once again, then answer the question, right? So let's look into it one by one. A, which is sum of two acute angle is an obtuse angle. What do you think? Is it always true, sometimes true, or never true? Sum of two acute means less than 90. If we add them, you get obtuse angle. Will it be true? Let's take an example. So if I do 60 degrees plus, let us say, 70 degrees, in that case, I do get 130 degrees, which is obtuse, right? That is correct. However, I could also have an example, which is, let us say, 30 degrees, which is an acute angle, plus 20 degrees. Now that gives me 50 degrees. Do you see that? But this is an acute angle. You understand? So that is contradictory. So therefore, this statement is not always true, but it is sometimes true. So we could write this as sometimes true. Is that clear to you? And that is the reason, okay? Because we have taken an example 30 and 20, which results into 50, which is an acute angle, not obtuse. Correct? Okay. Part B. Sum of two obtuse angles is a reflex angle. So let's try this. What happens if I have sum of two obtuse angles? So let's take a short obtuse angle, let us say 91 degrees, right? And then add another 91 degrees. So that becomes 182 degrees. So that is true, correct? So I think this statement is always true. Correct? See, two intersecting lines will form four angles. Let's draw and check. So we have two intersecting lines, and how many angles are there? Well, one angle, two angle, three angle, four angle. It seems to be correct, but no. What about this? This is also an angle, right? Correct? You know, and this is also an angle. So there are many angles formed. So this statement is not true, right? So two intersecting lines will form four angles. That is incorrect, right? So we cannot say always never. So it is never true, correct? So whenever two lines will intersect, we have so many angles, right? D. Two intersecting lines will form two straight angles. Well, two straight angles, let's draw the lines once again. So if I have two lines, well, there you go. We do have a straight angle here, and then we do have a straight angle here. So that is correct, and that means it is always true. Correct? Very important question from test point of view. Have a good look at it. Try to understand how we have justified our explanation also. Now, let's learn about another concept. We're talking about now pair of angles. It says angles are classified based on the fraction of complete turn about a point, which was a full circle. That is what we had seen earlier. Now, we will see different kinds of classification. We'll talk about angles, which when combined can give you 180 degrees or 90 degrees. So there are two terms, and we call them pair of angles. Two angles which add to 180 degrees are called supplementary angles, right? That is kind of one important thing to understand. So these angles may not be adjacent angles. Let's try to understand the statement. For example, if I add 60 degrees with 120 degrees, I do get 180 degrees, right? So these two angles can form a supplementary pair. So this is what a supplementary angle is. So a pair of angles which added to 180 degrees will form a supplementary angle, right? That is what it is. Okay. So sum of two angles is 180 degrees. Those angles form a supplementary pair of angles. That is how we say it. Okay. Now, the second one here is complementary angles. Now, for complementary angles, the sum of angles is 90 degrees. Okay, so that is how it is. So let me just sketch them for your benefit. So this will be kind of like this, and here supplementary will be, they will add up, and then they could become a line, right? But these angles could be not with any adjacent side common, right? That is kind of important. there could be two separate angles, but when you combine them, then they become one straight line or 180 degrees. For complementary angles, their sum is going to be 90 degrees as shown here. Is that clear to you? Correct. Now, there's another term which is kind of related. It's called the linear pair. Now, I've taken linear pair here purposely with supplementary angles, since there is a very fine difference between the two. A linear pair is a pair of adjacent angles formed when two lines intersect. So linear pair is a pair of adjacent angles as shown here. So one particular line, and on that line we are intersecting another line. So in this case also it adds up to 180 degrees. However, we have a common arm. Do you see that? So these two angles are called adjacent angles. Is that clear to you? So when you have adjacent angles, then we have linear pair. You get the idea. So it is a straight line formed because of the third line, but that line is common, right? So they are adjacent pair. So the only difference here and supplementary angle is that the supplementary may or may not have adjacent angles, correct? Okay. Now, lines which meet at 90 degrees are called perpendicular lines. So, if we have a line which is kind of like this, then in that case, these are the perpendicular lines. And again, they will definitely form a linear pair also. And the sum of these two 90 degrees will be 180, correct? So, that is a special case when the lines are perpendicular. Example 6. Are the following statements always true, sometimes true, or never true? Right? So now we have another interesting set of question. You may pause the video at this stage, answer the question, and then look into my suggestion. First question is, supplementary pairs form linear pair. What do you think? So this statement is sometimes true. Can you tell me why? Not always. Because supplementary pair means I could have two angles which are not adjacent angles. Do you get the idea, right? So I could have one angle like this and I could have one angle like this, correct? So if I have this angle, let us say of 50 degrees, and the other angle which is 130 degrees, then their sum is 180, correct? We know in this case we have 50 degrees plus 130 degrees does give us 180 degrees. However, they are not adjacent angles, so they are not linear pair, right? So we'll say not linear pair. They are supplementary, but not linear pair, correct? So that is a very fine line, and that is what you need to understand. Part B. Angles forming supplementary pairs are acute angles. Well, we have seen here supplementary pairs are found by acute and an obtuse pair, right? Otherwise, you cannot have. 90 plus 90 will give me 180, correct? So I cannot have two acute, so this statement is never true. So one of the angles should be uh, obtuse angle to form a linear pair. C. Complementary pairs are formed by acute angles. Well, the complementary pair is when we are looking for a sum of 90 degrees, right? So in case you want to add something, then these numbers have to be less than. So this is always true. Perfect. The last example here is three internal angles in a triangle are supplementary angles. So as you know, in a triangle, the sum of angles will always be 180, correct? So if I have the angles, let us say angle 1, angle 2, and angle 3, in that case, we know angle 1 plus angle 2 plus angle 3 is always equal to 180 degrees. Now the question is, three interior angles in a triangle are supplementary angles. Is it true or false? What do you think? I'm saying it is never true. Why? I know the sum is 180. However, when we are saying supplementary angles, we are actually looking for a supplementary pair of angles. And here we have three angles, not two, and therefore it is never true. So I'm not writing the term supplementary pair in this case, but whenever we talk about supplementary angles and the complementary angles, they're always pair of angles. Okay. Examples 7 and 8. Find the size of angle complementary to the given angle. That is example 7, and example 8 is find the size of the angle supplementary to the given angle. So I'd like you to pause and answer this question. Well, complementary means sum is 90 degrees, correct? So to find the other angle, let me do 45 will be what? 90 degrees minus 45 degrees, and that will give me the answer as 45 degrees. Then 80 degrees means 90 minus 80 degrees. That gives me 10 degrees. Now, how about x degrees? Well, in this case, we'll just write 90 minus x, right? 90 degrees minus x degrees. That will be our answer. So that is how you have to provide this answer. Now I think you can do part question example 8. The supplementary angles they add to 180 degrees, and therefore the general solution will be 180 degrees minus y degrees. Rest I think you can fill. Let's look into example 9 now. Find the value of unknown angles in each of the following. So I'd like you to pause the video and then answer this particular question. A, B, C, and D. Find these unknown angles. Angle A here. So whenever we are showing that 90 degrees, then we know these are complementary angles. And in that case, we can find angle A as equal to 90 degrees minus 23 degrees. Correct? So that is how you can actually find the answer. Correct? So taking from 10, you get 7, and from 8, we get 6. 67 degrees is our answer. In this case, that is a linear pair, correct? This is a linear pair. So can you find the value of B? Well, clearly, it is 180 degrees minus 30 degrees, which is equal to 150 degrees, right? So that's the value of B. So that is how you're going to answer this question. Now take a moment to answer the question of part C, which is we have now three angles which are making 90 degrees. Can you find the value of C? Well, let's figure it out. We know that C plus 50 is equal to 90 degrees, correct? So we have 2C equals to 90 degrees minus 50 degrees, which is 40 degrees, and C will be 40 degrees divided by 2, and that gives you 20 degrees. So the value of C is 20 degrees. Is that clear to you? When we write the same number or alphabet, then the angles are congruent. They are exactly same. So what we learn here is that two angles are exactly same if they have the same value, same rotation. Okay. Part D. We have to now find what is angle E and what is angle F. How do we do this? Well, E forms a linear pair with 180, so angle E will be equals to 180 minus 120 degrees, and that gives me 60 degrees. So that is one thing which we can write. The other thing which we learn here is that, well, if this is 120, then that is also a linear pair. That should also be 60 degrees, correct? Now we can find what F is. So F will be equals to 90 degrees minus 60 degrees, correct? And that gives me 30 degrees as the value of F. So that is how you're going to do it. So this 20 degrees forms a linear pair on both the sides, correct? So you could find the other angle also, and then 90 minus that angle gives you the answer. Now, let us try to understand more concept, more types of angles. Now, we'll talk about vertically opposite angle. So, vertically opposite angles, two angles directly opposite each other when two lines cross are called opposite angles. They are always equal. So, here what we see that the angle A and C, they are opposite to one another and they are always equal. And these are the two intersecting lines. So we normally write lines with, let's say, L1 and L2. So these are the two lines. which are intersecting at a point O, let us say in the center here, and the angles formed. There are four angles in this fashion, non-overlapping angles being formed. In that case, the opposite angles A and C are equal, D and B are equal, correct? So that is how we define a vertically opposite angles. Now, here is a proof that these angles are always equal. We actually applied this trick in the previous example, correct? See, A plus B will form a linear pair, right? This side of the line. So A plus B is 180 degrees. I can now write A as equals to 180 minus B. Similarly, C plus B is also a linear pair. So this particular line is also a straight line. So angle C plus B is also a linear pair. So C is equals to 180 minus B. Now both are equal to 180 minus B, and therefore angle A is equal to angle C. Is that clear to you? Perfect. Let's move on and take the next example, which is, okay. Now we talk about the transverse line, right? So transverse line, as we talked about earlier also, is a line which cuts two other lines. Now those two lines may or may not be parallel, okay? So any line which cuts other two lines will be called transverse line. So in this case, a line L3 that crosses two other lines is called the transverse line, right? So as you can see, it is only L3 which is crossing the other two lines. Therefore, there's only one transverse line in this particular diagram. Clear? Now, whenever it crosses, you can see I made so many angles, right? 8 angles are formed. So these angles are called with some names, and we'll understand how do we name them, correct? So whenever it forms, you get 8 angles. Do you see these 8 angles, which are labeled here from A to H, right? So these are the 8 angles. Now we'll begin with the first pair of angles, which is called the corresponding angles. So corresponding, as the name suggests, they have exactly similar position. So it says when two angles which are relatively in the same position are the corresponding angles. They are on the same side of the transverse line. For example, if I take the angle B, for example, right? So it is on the same side of transverse line and same side of the two other lines. So this angle is on the right side. So this is right side, right? Transverse line. And see, angle B is above, and this is above line L1. So here F is also above line L2. Do you see that? So they have exactly same position, above the two lines and on the right of the transverse line. So that set is the corresponding angles. So we get BF as a corresponding angle set, right? So you can identify the other corresponding angles in this particular diagram. Clearly, I could have C, and this is on the left side and below. So left side and below will be G. So that becomes another pair of corresponding angles. So likewise, there are four pairs which are mentioned here. I'd like you to confirm that these are the right pairs and try to identify these corresponding angles. Let's look into another type of angle which is called alternate angle. As the name suggests, they are like alternating, right? So in this particular case, we have two types of alternating angles. One is called interior alternate angles, the other one exterior alternate angles, correct? Name will suggest which angles to choose. Two angles which are in the opposite side of transverse line and between the two lines. So let's say D and opposite side will be E. Do you see they are in between? So these are between, correct? Between L1 and L2, correct? And they are on the opposite side also. So this is opposite to E. And that is why these two angles are called alternate angles. Well, the other alternate angles also you could identify. If I go outside, then outside, outside. Do you see that? So it could be even outside. So those are exterior alternate angles and these are interior. There are four set of alternate angles as mentioned here. So I'd like you to have a close look so that you can easily identify these angles. Another pair of angles is called co-interior angles. Co-interior, interior and co-interior. So that means they come together. So this angle D and F are co-interior angles. So there are two conditions to this, like they're on the same side and in between. So there are two conditions. So two angles which are on the same side of the transverse line and between the two straight lines are called co-interior angles. So we have basically two sets of these co-interior angles. That is another set of co-interior angles, correct? Now you learned about same side for corresponding angles also. However, in corresponding angles, only one was inside and one was outside. Remember that, okay? So we have two sets of co-interior angles as you can see here. Now let's have an example just to identify these angles. So now the question for you is, name the following angle pairs. So we have so many angles, but we want you to name what is C and E called. So C and E. So this pair is what? That is what I would like you to name. So that is what you need to answer here. Then B and G. So B and G. What is this pair called? A and E. So E is again marked, okay, E and A. So what is this pair called? Correct? The last one is E and H. So let me use another ink. Okay, E and H. E, so E is with many, E and H, these angles. So let's begin answering our question. I think you got your answers. C and E. So C and E. So we are looking for C and E. So these are on the same side and they're inside, right? Same side and inside means co-interior angles, correct? Now B and G. So B and G. So these are alternate, right? And outside. So exterior alternate angle. Now we have EA. So with E, we have to say A. They are corresponding same side, same position, right? So they are corresponding angles. Last E and H. So they are opposite to one another. So we can say vertically opposite angles. So that is how you need to answer. So I hope you have understood how to identify these angles. Now let's take case of parallel lines, right? So till now we are focusing on any lines. Now we'll concentrate parallel lines. So the green and blue lines are shown to you. They are parallel. Normally in the books, you'll find the arrows, the matching arrows. So matching arrows are placed for parallel lines as I've shown here. So when a transverse line cuts a set of parallel lines, then three angles, the three pairs which we talked about, they have a very characteristic property. The corresponding angles are equal, alternate angles are equal, and the co-interior angles are supplementary. So when I say supplementary, means they add to 180 degrees. Correct. So that is how the angles are. Now here is very important thing to understand that there is a pattern in identifying these angles. So for an alternate angles, we have a Z pattern. Do you see the Z pattern here? The alternate angles as shown are these angles which will be equal, correct? So Z could be either side, right? I could also have a Z in this side of patterns, right? So that is also correct. So either way, we could have a Z and we have an alternate angle, as you can see here. Now the other set is corresponding angles. Now corresponding angles form F. So we have F, right? So we have an F here. So that is how will identify the corresponding angles and you can place them at the same positions. So one position is shown here in the figure where one is topmost is in between and then we have outside. So that is the position of F. For co-interior angles, the figure formed is C, right? So we have a C to form a co-interior angles. So these angles are the co-interior angles. The shape is of a C. So that also helps you to identify the set of angles or the pair of angles. Is that clear to you? Now let's look into example related with this. Now we are almost at the end. We're having now test examples for you. I would like you to take this as a test question. Question for you. The transverse line L3 cuts the parallel line L1 and L2. So these lines are parallel, right? So these lines are parallel, as shown in the figure. Find the unknown angles giving reasons. So we need to find the unknown angles E first, then F, G, and H. So these are the angles. So we need to find what E is. We are given 130 degrees, right? So how will you find this? I'd like you to pause the video and then answer. We learned that in case of parallel lines, what do we have? We have co-interior angles. These are co-interior angles, right? So these are co-interior angles. Okay, in co-interior angles, the sum is 180 degrees. So that means E should be equals to 180 degrees minus 130 degrees, and that should give me 50 degrees, right? Since we know that sum of angles, so sum of co-interior angles is 180 degrees, right? We're talking about parallel lines and transverse line only in that case, right? Now, the next is we have to find the angle F. How do we find angle F when we know what is angle 130 degrees, that alternate angle? Do you see that? So these are alternate angles. So I can write this is equal to 130 degrees, and the reason is that alternate angles. You can also mention alternate interior angles. Now the next one here is to find the angle G, which is this angle. So from here you can see that they have similar positions, they're on the same side, and so this is the corresponding angle. So corresponding angles are also equal. So it is 130 degrees, and the reason is corresponding angle. Last is H. So for H, now how do you find H? Now in this case, directly from 130, it is not corresponding, not alternate, right? How do we find H? Well, we can find H as equal to angle E, and because these are vertically opposite angles. And since we found E earlier as equal to 50 degrees, I can say H is also 50 degrees. And the reason here is that it is opposite angle. Is that clear to you? So now we are going to use this angle E which we found earlier to find the angle H. Is that clear to you? So that is how we are going to answer this particular question. Now let's move forward and take up example 12. Example 12 is, refer to the figure below. You are given that F is equal to E. So you're given that these two angles are equal. F is equal to E, right? These two angles are equal. So normally, if I write one dash like this, it means equal. Now here, we are showing this means is an isosceles triangle. Do you understand? So we have an isosceles. That means two angles are equal, right? Okay. Now that is the case. Find the measure of angle A. You need to find the measure of this angle A. You can pause the video, answer this question, and take it as your exam review. Tell me, how are you going to find it? Well, you can find angle F, since this is a linear pair, right, as equal to 180 degrees minus 100 degrees. That should give you a hint. So that is 80 degrees. Correct? Now, once you find F, you know what E is, right? So E is also 80 degrees. Since we are given that both are equal, right? This is equal to F. Now, what is C equals to? C is 180 degrees. Take away F and E, right? Take away F and E. Because we know that in a triangle, the sum of angles is 180 degrees. Correct? So that is how you're going to do it. So that will be 180 degrees minus 80, right? 2 times 80, right? So that leaves us 20 degrees. And C is actually equal to A. And this is equal to A. So we know A is 20 degrees since they are opposite angles. So that is how you're going to find the solution of this question. It's a very tricky question. Try to do it once again and understand the concept. Question 13 is also a part of exam review. I'd like you to look at this question, understand, and then answer. Refer to the figure below. Find the measure of unknown angle x and y. Provide complete solution with reasons for each statement. So you need to find x and y. How would you do it? Okay. So these lines are parallel, those lines are also parallel. So now what can we do? Well, we have these two parallel lines, so that becomes a transverse line. And if you notice, on this transverse line, angle 50 degrees, that should also be 50 degrees. Correct? So we get a point which is 50 degrees, and the reason for this is corresponding angle, right? You can label this, right? So that you can communicate better. Let's call this point as O, A, B, C, D. So in that case, we can say that the angle COD is equal to angle BAO because they are corresponding angles, correct? And so we get this as 50 degrees. Now, once you get that as 50 degrees, now you know x can be found using properties of triangle. So in a triangle, sum of interior angles is 180 degrees. That is a property which we'll use. So x will be equals to 180 degrees. Take away 50 degrees. Take away 55 degrees. And that is how we're going to get the value of x. So in this case, when I take away 50, I get 130. And from 130, we take away 55. So 5 take away, this is 5, and from 130 it became 12. 12 take away 5 is 70, right? So we get 75 degrees. So you can actually check this. 50 for plus 50 is 105, and if I add 105 to 75, I do get 180 degrees. So x is 75 degrees. So we get x equals to 75 degrees. You get the idea, correct? Now, how will you find the angle y? Now you know that these two are parallel lines, correct? So when these two are parallel lines and we have a transverse line right there, in that case, how do we know what is this angle? Again, this angle is same as x, correct? This angle is x. And we know x is 75 degrees, and so we can now find y, which would be 180 degrees minus 75 degrees minus 50 degrees. Correct? So from our calculations, we can find the answer. So when you take away 75 from this, you get 105, and you clearly get 55 degrees as your answer. So that is how we could actually answer this particular question. So I hope it makes sense. So we have used the property that in a triangle, sum of all the angles is 180 degrees. Remember that to solve all such questions. Now this is the last question for you, which is again a part of exam review. So when I say exam review, then even grade 9 students can try this, right? Now, these are also very good for EQAO. Now, in this particular, you have to refer to the diagram and find the value of xy. It means product of x and y. Provide complete solution with reasons for each statement. So that is how you're going to do it. Let's see. So first we find that this angle is 40 degrees, that is x plus y, they should be equal, right? And then we need to find what that 2x minus y is. I think you got an idea. You can pause the video now, answer, and then look into my suggestions. So let me get one equation here, which is x plus y equals to 40 degrees, since these are vertically opposite angles, right? So vertically opposite angles. So that is in the short form. How do I relate to x minus y? Well, we have a linear pair. Well, if that is 90, this is also a complementary pair. So in that case, we can say 2x minus y is 90 minus 40, which is 50 degrees, correct? So we have two different equations. Let's call these equations as equation 1 and 2. Now, if I add them, what do I get? So when you add, 2x plus x is 3x, minus y plus y cancel, 50 plus 40 is 90, and so you can get x equals to 90 by 3, which is 30 degrees. So you get the value of x as 30 degrees. You get the idea. Now if x is 30, then in that case, what is y? Well, this is the equation. Y should be equals to 10, because 30 plus 10 is 40. And now once you have both x and y values, then you can find what is x times y. So now we'll multiply x with y, which is 30 with 10, and we get our answer as 300. So that is the answer, and that is how you're going to find it. So I hope you find it interesting and useful. That was slightly more complicated. It is basically meant for grade 9 EQA test paper. So I hope that helps. Feel free to write your comments, share your views, and if you like and subscribe to my videos, that will be great. So we learned all these concepts, and I think with this review, you can easily solve any question for middle school and also many questions for grade 9. I hope that helps. Thank you and all the best.